6.6, functions and their inverses. Okay, first of all, what is an inverse? So we talked about this in the past. We're going to bring it back to light here. So a function x is equal to x. Let's say it's just a basic thing. Essentially what we do for inverses is we first think of f of x as just your y, right? So we think of that first. And then really the next thing that we do here as our step is we switch the x and y. So it literally looks like this, x equals y. And then you resolve for y, right? Now in this case, there's not much to it, right? Because then the inverse of x and y happens to be the same. But then we use function notation. We say the inverse is still equal to x. Now it looks a little different. Let me give you a better scenario on this. F of x equals x plus 2, right? So then what we do, we write it as y equals x plus 2. We switch x and y. So x equals y plus 2. So really just switch the x and y there. And then we're going to go ahead and solve as we normally do. So I'm going to subtract 2 from both sides. So then I get x minus 2 is equal to y. Reconvert it, so it's y equals x minus 2. And then we put the notation f of x inverse, because we did something to it, is now this. So the inverse of the function x is x minus 2, where the regular function was x plus 2, right? So that's really it, right? So we are going to go through this step here. We'll do a couple practice problems to get that going, right? But again, if you need to write it down for yourself, right, replace f of x with y so we see it, switch x and y, resolve for y, put it back into its notation. Something basic like that, right? All right, second piece here. How do I determine if a function is a legitimate inverse, right? Legitimate inverse. So we want it to continue to be a function. So we do this thing called a horizontal line test. So a horizontal line test checks that a function has a legitimate inverse. Okay, so every function has what we'd say an algebraic inverse, but does it graphically look the same way? So a horizontal test, so if I had a function like this, I'm literally going to just, let me throw a horizontal line in here. As long as it only crosses the graph at exactly 1 point, we're good. If it crosses more than 1 point, it does not have a true, it has maybe what looks like an inverse, but it's not going to be a true inverse. So let me show you what I mean. So like x squared, which is a parabola, right, might look like this. So if I were to try a horizontal line test, it hits here, it hits here. And it doesn't matter where it is, because we're going to try the whole thing. If it hits twice, 1, 2, it's not. So the inverse is not a function, right? Because the problem is we would end up with 2 possible answers for the same value, and we don't want that, right? So that's what it looks like there. So that's called the horizontal line test. We'll do a couple problems just to see, is the inverse of the function actually there? All right, how can I test that 2 functions are inverses of each other? So if we want to know, are 2 functions actually inverses of each other, we are going to use a composition function. And so what you should be able to do, here's the test. If g of x, g of f of x, right, a composition function, if it equals x, and, or, I guess you could say the other way to do it, is the f of g of x also equals x. As long as both check out, we have function inverses, right? And that's really it. It's a pretty simple, it's a composition, right? So remember, compositions can be shown many different ways. I can show this as g of f of x. That's one way to show that. So this one then would be shown as f of g of x. So we're just going to test them out. All right, so this is kind of for your notes section. Let's do a couple examples. All right, here's the first one. Use the horizontal line test to determine whether the inverse of the relation is a function. So we're going to start throwing horizontal lines on this thing, making sure, hey, it only crosses one at one point. Right? Now it can cross at no points, that's fine. 1 point. 1 point, right? So all of these seem to be fine, even though that it doesn't have a line going through it all. Every time I do a horizontal line, it only hits 1 point. So is the inverse of the relation a function? Answer is yes on this one. All right, let's try on this one here. Looks good there. Looks good there. But let me come up here. Bad. 1, 2. You hit it twice. That means its inverse is not a function. Let's try this one. Yep. 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 So it doesn't matter where you go. I'm only going to hit it once. I don't see any problems with it. That's going to be a yes. That's called the horizontal line test. Literally start throwing horizontal lines. If you hit the graph or the relation at any 2 points on that one horizontal line, we got problems. Otherwise, you're good. Okay? So that's what that one looks like there. All right, find the inverse of the function, determine whether the inverse is a function, and state its domain and range. Okay, so here we go. Ready? Let's go through the steps. First, change f of x into just the y. Okay, let's switch x and y. Right, so notice I just literally switch them where they are. And let's resolve for y. Okay, subtract 21 from both sides. X minus 21 equals negative 3y. Divided by negative 3. Divide everything by negative 3. So let's just leave it as one big x minus 21 over negative 3 is equal to y. But then let's just put it back in its notation. So I'm going to flop these two things where they are. But instead of writing y, I'm going to write f of x to the negative first power. That's how we denote that it's an inverse. X minus 21 over negative 3. So, and we might be able to clean these up a little bit, but right now we just want to see its basic right here. Okay, so that would be yes, this is the inverse. Now, is the inverse a function? So what you do, you'd graph this and you just make sure it passes the horizontal line test. So we could try that if we need to. Domain. So domain, what we're going to do is say, are there any x values that give us any problems? And in this case, no, I can throw in any x value I want. So my my domain is x is equal to all reals values, right? So you can do that all you want. All right, and then range. So what range? Range is y is equal to all real values, right? I'm not restricted at all on that. Okay, here goes the next one. You ready? So change g of x to y. Let's switch x and y. And let's resolve. So x plus 9 is equal to y squared. Y, I'm going to square root this side is equal to the square root of x plus 9. But it's really plus or minus, right? That's what we'd have to do on this. So y, let's not do it y, it was originally called g of x, so let's put the little g of x inverse is equal to the square root of x plus 9. Okay, so Again, we could put this on to in our calculators, make sure it passes the horizontal line test. That would determine whether it is a function or not. Domain, are we restricted on the domain? Absolutely we are, right? Because we can't have a negative number on here. So we got to make sure that everything that's underneath, x plus 9, stays greater than or equal to 0. So x would have to be greater than or equal to -9. So we have just talked about where our domain has to be anything greater than or equal to 9. So if that's the case, if I put the smallest possible value, -9, in here, what would I get for y? Well, y would be 0 at that point, but then anything above -9 is going to give me anything above 0. So there you go. There it is. All right, let's try this one right here. All right, y equals x plus 5 over 8. Switch x and y. X equals y plus 5 over 8. All right, now we want to undo. So multiply by 8, multiply by 8. So now I get 8x is equal to y plus 5. Subtract 5, subtract 5. So now I'm going to get 8x minus 5 equals y. So I'm going to rewrite this. Inverse of h of x is equal to 8x minus 5. Again, we could put that in and make sure it's not, it's a horizontal line test would pass. Domain looks like all real values. The range looks like it's also going to be able to be all real values. There's no x value that's going to give me a problem in here. All right, so that's what we're doing on those. So just switching x and y, resolving, and trying to figure that out. And then let's do the last one. Determine by composition whether the pair functions are inverses of each other. So what we're going to do, we're going to do f of g of x and make sure it equals x. That's what we're trying to check for. So here it goes. I'm going to take f of x, but everywhere I see an x, I'm going to plop in the entire g of x into it. So it's going to look like this. 4 of negative 4x plus 8, close it, minus 12. This would be f of g of x, where we're literally putting g of x into wherever we saw an x for the f. Okay, let's do it. Negative 16x plus 32 minus 12. So if I put these together, negative 16x plus 20. That is not x. Therefore, these are not inverses of each other. Okay, let's try the next one. Here we go. Let's try it again. So let's start this f of g of x, right? And we're trying to see, does it equal x? This is our goal. So everywhere I see an x in the f, I'm going to plug the entire function g of x into it. So it's going to look like this. Square root of 3, instead of an x, we're going to put x squared over 3. And then we're going to have that. Okay, let's start evaluating. The 3's will cancel each other because it's 3 divided by 3, so it's 1. So now we have, after the cancellation, we have square root of x squared. Those go away. We have x. Hey, this is good. This looks good. But we also need to, now let's just flip it and make sure it's going to work the other way. G of f of x. So what does that mean? That means we are going to take all of f of x and plug it in everywhere we see an x in the g of x function. So it's going to look like something like this. Square root of 3 of x squared over 3. Okay, now let's start evaluating. The square and the square root cancel each other off on that top. So then we got 3x over 3. 3 divided by 3 gives you 1, and we are left with x. This works. So therefore, these two functions up here are inverses. Yay! And we're done. That's what it looks like, right? So that's what you're going to need to be doing on this one right here. What is an inverse? Well, let's figure out how to solve it. right? So switch x and y and solve. How do you determine this function has a legitimate inverse? It's got to pass the horizontal line test, right? And then composition functions, as long as f of g of x and f and g of f of x equal x, we have functions that are inverses of each other.